Thank you. Good evening from Maryland, USA. Okay, it's going to be midnight soon. And together with me is Dr. Chiang and also Julie. Okay, and you know, I think I will ask some questions. Okay, I mean about Dr. Tsai's presentation, talking about all those forestry in Taiwan, National Taiwan University, and all the research done related to the carbon sink and the greenhouse gas emission, or how the knowledge we learn from the experimental station research and can be applied to some of the private land forestry in Taiwan.
Okay, thank you, Dr. Wei. And our experiment, the forest also adapt our knowledge to the private land, to plantation the new trees, and estimate the carbon sink. And we also following the methodology of the government from the Taiwan government. So our knowledge also provide to other corporate company to doing this. And for example, last 2 weeks we doing that in one country, and we plant 1 hectare and plant domestic tree species, and make sure 20 years grows up. And this are our effort to our knowledge to the society. Yeah, that's all.
And how about the choose of the plant species? Well, you know, we're talking about to accelerate the process. Or you guys are thinking about, you know, adapt the different kind of the trees?
Yes. Yes. We plant the trees, choosing we consider the climate change, maybe some extreme drought, maybe some flooding. So we select domestic trees, tree species, and maybe it must be to survive past weather drought situation. And our selection, and also we select another is must be growing up very flexible. So we select 3 or 4 tree species. It's a kind of broad-leaf tree species, and also planting in the country, and the land is abandoned. So we cooperate with the local government, and select one land to doing the model, and we encourage all the abandoned land to plant the trees.
Okay. Now another way is, of course, people apply the genetic engineering, trying to modify or identify some of the specific site so that make the certain tree to grow faster. So do you guys do some of those
No.
CRISPR?
No, we just using the domestic tree species, but not the genetic, using the genetic selection. We just following, but we select the healthy mother trees, collect the seed and silver, and plant and replant to the wild. So we select the mother tree, not using a genetic selection.
You know, Julie, when you talk about some of those approaches, you know, you talk about different crops, different crops, vegetable or fruits or whatever. And do you think about some of the, you know, some is long-term goal, some is short-term goal. And if you take a certain kind of actions, maybe you can see good result in the short term. Something like that.
I'm sorry, you're saying that, do you see short-term results? Is that what you're saying?
Short-term result, I mean the beneficial results.
Mhm.
Okay. And
But-
I'm sure you consider this, but
Mhm.
you know which way to adapt or to, for example, okay, you talk about soy, I mean the cotton, okay, and then another one you talk about some of the plants or some of the trees or whatever, and then because the farmers or the industry you try to serve, they are different, and that's because you know sometimes this basically trying to compete for the resources, right? And you have you know $65 million, and they want some, for example, if the cotton industry, they say, hey, you know, we want more attention, we want a bigger share of your resources or your effort or something like that. You know how you're going to balance some of that. Yeah.
Oh, I see what you're asking. So yes, so we have already pre-allocated money to different commodities or
Yes.
different types of commodities. And we've based this in an effort to try to answer some of the questions. Because part of our project is to provide funding for people to do the climate smart practices, but the other part of it is to actually learn
That's
from
right.
from the project. And so our selection process will include a variety and make sure we're including a lot of the commodities. But the other side of that is to select participants where we can gain the most amount of knowledge from what we're doing. Because our goal is to figure out how to best do it. And I know that there's a lot of research in different areas and different, you know, and the thing is, not everything works the same way in every ecosystem. And so that's part of our challenge, is to try to select things where we can actually test some of these things to really see what works and doesn't work in different regions for different commodities, so that we can start providing that best management practice type of knowledge back to those producers. You know, maybe in forestry, it's afforestation, maybe it's in cotton, maybe it's putting riparian buffer strips near the streams. I don't know, but looking at those different land management practices and making it specific for that operation and trying to figure out what's working is kind of our goal. So it's kind of hard because we're trying to figure out so many different things at the same time that I'm, you know, we're trying to overlap several different things, but that's how we have so many different people working on it.
And,
Did that answer your question?
No, yes.
Okay.
But the question, I mean, not a question. The challenge is, okay, you're going to coordinate so many different variables. And then okay, you mentioned about some specific project for certain industry, and maybe because they're located in certain area, the soil type, the temperature type is different from what you're doing. And in that case, sometimes you may also want to adapt some of their findings and apply what they learned into what you're going to do, right?
Yeah, so it maybe we have to cut it down a little bit, but we're going in with let's see how many different questions we can possibly answer with the pool of people that are willing to participate in the project. So that's kind of where we are now. We're just in that trying to get it set up, and hopefully we're recruiting farmers by the end of this year. That's our plan.
Now, how about other people's? Do they have any questions or comments?
Yeah, so hello everybody. A great discussion. There was one question from the panel addressed to me about the carbon usage to support the growth of the agricultural crops and for the carbon taking. So I was more looking into that from my presentation, for example, from the biogas usage perspective, that if you are using, for example, biogases to power the agricultural equipments and tractors and so forth. Actually, we have a quite circular economy use case there. We're actually using the let's say produced from different side streams to produce biogas, to use that again. So I see that as supporting the agriculture in a way that we are more circulating the energy side flows and also the nutrients within the cycle. And I think another example that I did highlight in my presentation was the connection between the engineering education also and engineers solve challenges. So I think there are a lot of technologies available, but I think the focus is how to apply those in the use. So there's a lot of, for example, research done, and there's availability of for example, lighter materials, special steels and such that would be applied to farming areas, so that we have more lighter equipment that can carry more load or have more fuel economy better in that terms. So I think there's a lot of technologies available, but the application in a wider scale, that is the challenge, that how do we take those into use that would have then a climate changing impact or fighting against the climate change. So I think that we are trying to assist as a higher education institute to ensure that we are educating engineers. That could be one of part of the solution to apply and take into usage a lot of available technologies and scale those in agriculture. And of course, then we are talking about a lot of technology and surveillance of the crops and irrigation and these kind of things that can be supported by the new technology. So there's a lot of opportunities, but I think challenges we have currently, that how do we apply, take into use, even though when the business case is can be a bit higher for the cost, how do we then look forward in the future? That's my answer for that question. Thank you.
I have one question.
Go ahead.
Yeah, Julie, thank you for your sharing. Your research is very big scale, and I'm interested how you organize these 75 researchers and put it together. And when you write the project, you don't sleep for over 1 month, I think, right? Otherwise, how you can collect all these people's knowledge and put it together in our proposal? So my first question is how this proposal get done? That's my question. And for Ville, I also have a question for your degree program. And my question is how you do the promotion for your degree program to make more students apply to your program, and what kind of student background that you like. For example, the student came from a management college or from agricultural college or engineering college, or it doesn't matter. Okay, that's my question. Thank you.
Okay, I guess I will start with the question one. Yeah, it was about a month and a half. I didn't sleep, and I spent a lot of time on Zoom and Teams, meeting with people and discussing them, because I'm not an expert. I think somebody asked me about cattle. I'm not an expert on that. I spent most of my time trying to organize people and trying to figure out the best contributions and way to bring everybody together to make a project that would be cohesive and have a success. Sometimes I think we're over ambitious, and then sometimes I think we're under ambitious, but anyway, it was a lot of work. You're absolutely right. And you just have to, I mean, I really am passionate about helping people improve sustainability of agriculture. And to me, this is a win-win, improving the sustainability of agriculture, as well as hopefully help mitigate climate change at the same time. So that's where we worked on that.
Okay, I got a question. The question is, how does carbon sink work in agriculture? And they say since farmers from differently, okay, since farmers farm differently in different areas and the scale is different as well, how can utilize the average farmers into action, and does crops like the veg and the fruit or coffee work well in carbon sink? I think that's the same issue as the trees. Okay, so a lot of times in agriculture, right now people trying to do, some of the, do research, genetic engineering, and trying to grow the crops faster, or use less water, or use less fertilizer, so then they can produce and faster and more, and also meanwhile reduce the use of the natural resources. I mean, right now, for example, some professor in my college, they use CRISPR trying to improve the some of the fast-growing trees, and that's one sense. The other sense is, of course, that's the major one. Okay, the other one in some others is reutilize some of the resources. And for example, we use some of the agricultural waste, and right now we are trying to reduce the agricultural waste, and a lot of the food or some of the crop produced is, was thrown away because they don't look as beautiful as the one they sold on the market, but those crops still can be reutilized. So we use some of the biotechnique. So for example, use the fermentation methodology and trying to convert some of the good food components into some of the nutrient factor and some of those supplement the diet or something like that. Okay, so that's another way trying to better control the carbon sequestrations and use the natural resources. So basically use the technology. Okay. Now I have one question for Ville. Your new programs or modification of the mechanical engineering, those programs for related to sustainabilities, and those changes, does those changes bring in more students major in those areas?
Yeah, so thank you. I think that Dr. Lee was addressing an important point that how do we promote the program, and what kind of student background we're looking forward. So as this program is ended mainly for students coming from the high school or from the vocational path, looking for a higher education like a bachelor degree, I think we have a quite wide variety of backgrounds that students can come from. Naturally, this is an engineering degree program, so our emphasis in exams that are taken as admission. There's a focus, of course, in mathematics and physics in certain degree on those entry admission exams. But of course, there's more like logical reasoning, English skills, and that kind of things that are also part of that. Actually, our main admission route is this. Finland has this global, let's say, admission exam program that's joined by the University of Applied Sciences, but we also have a special admission route that we are applying these entry exams. So I think that the students should and willing to have a engineering mindset in a way that they have basic physics, mathematics skills. But I think that's the entry exam point of view. But otherwise, they can come from a wide variety of background. And also, we have an open university access route. By doing a certain amount of credits in the open university, they can be admitted to the program. So there's a different routes how to access the program, and it's an international call for students. And usually we have the special admission during the November-December frame, and then the general admission we have in January-February. So there's a different routes coming in, and hopefully we're attracting students that perhaps weren't considering engineering as a career choice or education choice, so a bit wider audience than the normal engineering programs are attracting to. But like I said, we are just getting started with the program, and coming years will be showing that what is the general interest level and how much we are getting people interested to apply. But very, very interested to see the next coming years, how it's going forward.
Thank you.
May I ask
Okay.
one more question?
Okay, go ahead.
Yeah, Julia, my question is that how you find two organizations in your project? Because I saw that in the bottom of your slides, you have two organizations. One is NGO, right? So how you find one NGO and the other one is not NGO? I don't know I'm correct or not. How you find them to be a part of your project proposal, and what's their functions? Because IAAS, we also recently we have so many international international organizations. Either we are their partners or they are our partners. Maybe we can do something cooperate with you. That's what I'm thinking too. So two questions. First one, how you find two? Second question.
You're asking about the B carbon and nori? Yeah.
Yeah.
Okay.
Yeah.
So
Yes.
those are carbon aggregator companies, and B carbon is actually located in Houston, or their founder is in Houston. And so we have ties to them through, not really ties, but we just know of them through being such close proximity to them, since we're about an hour and a half away. And so one of our former students is now working for them. And so we kind of got connected through them. And then Nori is actually, I don't know actually how we got contacted with Nori, because one of my colleagues mentioned that they were interested in talking to us about some of these projects, and they knew we were putting a proposal together, and so they asked us to be part of it. And we were like, yes, that would be great. So sometimes there's a stroke of luck. And same thing with our Texas State Soil and Water Conservation Board. That was kind of an accident. We were talking to some people about this project. The other people were trying to put together a proposal, and then they realized how much work it is to put these proposals together, because they've never done some of these large USDA proposals. And so we were talking to them, and they were like, maybe, and we were just sort of thinking, it's like, maybe this would be a good partnership, instead of having both of us apply and compete against one another, work together for a bigger award. So originally we were thinking of a much smaller award, and they were thinking of a much smaller award. And so we just combined the two projects to make a better, more organized project. So I think I answered that. And as far as partnering, I mean, I know B carbon, I don't know about Nori. I don't know Nori as well as I know B carbon, but I know B carbon as projects internationally, as well as domestically, and they're a nonprofit. So, I mean, I think they would be very interested in doing types of projects, but I can't speak for them.
Hi, Dr. Wei. We have received a question from one of our participants, Dr. Divashi Chobi. So his question is for Dr. Ville, like about carbon sequestration in soil using biochar. Is that proven? What typically are the side impacts to typically grain crops? So I'll hand it over to you, Dr. Wei. Thank you.
To grain crops.
Yeah, so quite question. So I think what I was addressing in the as a presentation of the projects that we have been doing is that if I take from the technical point of view, this biochar production is replacing something in the production that is not biochar, so bio-based. So basically, where we are applying this in a let's say technology point of view is that how do we are making, for example, a carbon-free, carbon neutral steel. So if you know steel making, that is needing char to extricate the ferron from the so I think it's replacing something in the processes that it's not bio-based, and seeing how does it work in a let's say in the cycle, if of course that we are turning the biomass in a biochar that can be then applied to for example replacing or doing some energy production or using as a stable carbon to produce. So I think this is a well established way that we are actually using, for example, to have fertilizer to the forest to using the char. So it's a chalk based, and there's certain chemical properties. But it's a wide question, and I think it needs to be more addressed in details. But my take is that we are replacing something that it's not bio-based in the production, and that way it's already reducing the carbon emissions. But of course, the challenge here is, like my previous talk was saying, that how to apply that in a wider scale. Still, we have a certain amount of production happening, but not in a quite large industrial scales yet. That could be replacing in a wider term in society.
Thank you. Thank you for answering, Dr. Ville. Dr. Wei, we have one more question from one of our participants, Mr. Shmuel Yerushalmi. And his question is it according to you that captured carbon in agriculture can support improvement in agricultural crops? So that is his question. Thank you.
I would say it's always based on the improvement of technology. Okay, the more we, for example, we talk about this vertical agriculture productions. That is one way to improve the use of the land and also the resources. You use some of this hydroponic agriculture. That's another way trying to improve the recycle of the natural resources, water and the fertilizers, something like that. So that's another way. The other one is, of course, always the genetic engineering, use CRISPR systems to improve and increase the efficiency, the duration of the time, production time, all like that. And the other one is, of course, trying to reutilize some of the resources. I mean, some of the fermentation products, for example, you use the soybean and produce some of the fermentation product. And after that, usually what is left is used to be to feed to the cows. And now, you use some of the other fungus maybe you can extract some other nutrient and then eventually convert those material originally is discarded, you know, and produce another kind of the new products. So some of that is the way in the agriculture or in the food technology and the people use to better utilize or better productions of new products. So that's the technology, I would say. And that's what a lot of the faculty, they're doing research in those areas. They use these approaches. How about other people, any other answers? Discussion.
I have no answer, but I have one question. Can I?
Yes.
Yeah, I have a question for Dr. Julie. And do you know the MRV for the soil carbon credit in Texas? Do you have any MRV method?
You're saying to quantify the carbon?
Yes, and maybe to the measurement and validation and put on the carbon market. Do you have any method and or any actually the case?
Yeah, that's actually a great question. The methods are not, they're right now in the US, they are very much specific to different systems. So like that's one of the reasons we really liked our two partners, Nori and B Carbon, because they use completely different strategies to quantify carbon. One of them is entirely remote sensing and data collection. They don't do any sampling. And the other one is more traditional sampling and testing, which is a lot more expensive. And so this is something that we're really interested in looking at is, you know, do these things come up with the same numbers? Because even though Nori isn't taking samples, we will be taking samples. So we will be able to see if what they're doing is quantifying them accurately. And so I think this will be a really interesting set, because we'll have a data set to support or negate what they're doing. So I don't really have a great answer for you, because I think there's all these different companies do it differently. And so that's one of the things we're kind of interested in is does it work, right? And we're also, like I said, there's a lot of people in Texas that are pretty concerned that the carbon aggregation, the carbon market system is not going to be very useful unless you are in the forestry system or in lands that are heavily degraded and really have the potential to be built up. But our climate doesn't usually support. I mean, we're not in Canada or someplace where there's a lot more rainfall and a lot more organic matter. And so I think there's some concerns that that's not going to pay. But I also look at it as, well, you know, it may be it may be something. It may not pay for the practice, but it might be something to work toward to build up. But anyway, so that's kind of what we're anxious to see that answer as well.
Do we have any more questions or comments? If not, we can conclude the year, right? Okay. So thank you, everybody. It's nice to know you. Thank you.
Thank you.
Mm-hmm.
Thank you, Dr. Cheng-I Wei, and all panelists for the wonderful discussion.